Alright, let's continue with video number 4, the SVP editor MBvelocitytool. In this video we are going to cover the following topics: what MBvelocitytool is and why it's vital, how to launch it and load SVP data, how to use its visualization and editing features, how edits affect bathymetry in real time or near real time, integration with MB process and your workflow, plus some best practices and limitations. But before we do that, I just want to show you a few examples. Here we can see the variability of sound velocity profiles taken in a certain area over a period over a month. As you can see, there is a lot of variability. Therefore, it's not very uncommon sometimes that we take a SVP, we apply it in the acquisition software, and the data is immediately wrong because we just took it at the wrong spot, and then we just had bad luck. But since we spend a lot of time in this area, we could measure it quite consistently, and we have a good idea of the variability of the area. So in case you apply a wrong sound velocity, for instance, you get something like this. So this is the data before I applied the correct sound velocity. Here you can see that the surface is bended down by having a wrong sound velocity in the acquisition software. And after I did some modeling and was checking with several SVPs in the area, I found a suitable SVP who basically corrected this problem. So now let's start MBvelocitytool. All right, similar to what we did with MBEdit, I will restrict the capture area so that it matches the size of the window. In this example here, I will already load a file. And now I have to move the window inside the capture area. All right. So what we can see here is that the data was loaded, and we can see the array paths of the data. And here in the residuals, we see this very grotesque surface. The reason for that is because to apply sound velocity corrections, we need normally a flat surface. And what this window is showing here is that I'm applying a plane and I'm subtracting that plane from the data, and then what I should see when I have a flat bottom is that I should see the deformations of the bathymetry data based on a wrong SVP profile. But in this case, the data is completely contaminated with morphology. And to correct that, I have to change to a different file so that I can actually see the seafloor properly. For that, I will then switch to a different file, which in our test or sample data set is file 0010. And now if I load that, I can see that the area is at least bended as it expected to be if the sound velocity is wrong. The reason why the sound velocity is wrong here is because what is getting applied is just basically a constant sound speed. In order to correct that, we have a few ways. One way is that I basically use this reference sound velocity profile, which is basically calculated using the Leftos dataset. So when I import a bathymetry file, the tool immediately goes into another tool from MB system, MBvelocitytool, extracts sound velocity and displays that here, but doesn't apply. That should be mentioned. So one thing I can do is, for example, is that if I use the tool called MBSVP list, I can extract the sound velocity that was applied on during the acquisition, and then I can display it here as a display profile or editable profile. The editable profile is the one that we see the dots here, where I can drag the dots so that, for example, I can try and match slightly this profile here. And now if I apply reprocess, and if you look here, you can see that I improved quite significantly the bending on the surface. So let's try now. I load the as an editable profile, this one, the actual sound velocity that was applied on the data. So I have it here as existing SVP, extracted using MBSVP list. So if I now apply reprocess, I can see that actually the sound velocity that I had was slightly wrong, because it actually made the surface bend down at the edges, and what we want is a perfectly flat surface, or as close as flat as possible. So one thing that we can do now is that we can, since I don't have a lot of SVPs in this area, like I showed in the presentation at the beginning, I will zoom in and try to fix the problem. So let's, no, wait. I'm moving in the wrong direction. Okay. The depth, we can keep it. Okay, now I have. So obviously I cannot, in this editable SVP, I have hundreds of points. Well, I cannot drag these points because it will take a ridiculous amount of time for me to do that. So what I will do is that I will open a new editable profile that will replace that one with this one here that I prepare, which is again the straight line. And if I apply that again, the surface is very wrong again. So let's now match the Levitus profile. And what I'm doing here is I'm pressing the middle mouse button or the wheel, and I'm creating extra points so that I can drag them and make the fitting of this curve better by creating more nodes. And now if I apply reprocess, still not good. Why? Because I'm not extending the profile the whole depth. So if I now add more points here and apply reprocess, then I get better and better. So the whole thing is that I have to increase the depth to the maximum, and here the range to match, so that I can actually drag these points and make the curve fit. Although I have to mention that here the depth of this data is around 5,000 meters, so I actually have to match up to here, and everything else is not so relevant anymore. So I apply reprocess, and I'm slightly getting better and better. And then the things that I can do is that I can actually go to the surface, more or less, of the profile, and then I can see the very beginning of the profile, and I can see that here I'm not matching that, so I will actually add an extra node, and then I apply reprocess, and yeah, in this case I didn't get any substantial change, but I changed that node as well. I apply, no big change. But as you will see now, if I open another profile and I open the profile that was in the data, you can see that the profile that was in the data was significantly different from the one that I'm actually applying. That's why when I applied that profile, the data looked worse. So that's why a tool like this, MBvelocitytool, exists, so that we can load several sound velocities and then model one sound velocity that fix the sound velocity problems that we have in the data. And I think with that we conclude this video. All right, bye bye.